Welcome. This video is for everybody who was absent today as we were finishing on proofs, or if you just think you need a little bit more practice on the ones we did in class today. So this is on page 8 of your packets that you have, and this is the lesson for Thursday, October 17th. So I'm looking at this picture. I've got two parallel lines here, and I want to prove that the corresponding angles are congruent. So we know that they're congruent because we've talked about it before, but we've never actually proven why they're congruent. So when I'm setting up a proof, I set up my statements on one side, my reasons on the other. And for this one, I filled in the statements for you already. So the first statement was AB is parallel to CD. The reason we know that is because, well, that was given information. The next statement, angle 1 is congruent to angle 3. So angle 1 is congruent to angle 3. The reason those are congruent is because those are vertical angles, and vertical angles are congruent. That's a theorem we've already proven. My next statement, number 3, says that angle 2 is congruent to angle 3. So angle 2 is congruent to angle 3. Now, you should be familiar with this sort of picture by now to know that those are alternate interior angles. And anytime your lines are parallel, those alternate interior angles are always congruent. So I wrote that parallel lines cut by a transversal form congruent alternate interior angles. So I mentioned that the lines are parallel, that they're cut by a transversal, and that those are the alternate interior angles. You need all those pieces for a concrete reason for why those are congruent. It doesn't need to be those exact words, but it needs to be something to that effect. So now if 1 is equal to 3, and 2 is also equal to 3, then I can just substitute this value for 1 right in there to say that angle 1, this angle right up here, is congruent to angle 2, which are those corresponding angles, which is what I wanted to prove. And the reason we could do that is just by the substitution property of equality. Number 2, prove if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. So if the lines are parallel, those angles right there, that 1 and 2, need to be congruent. So notice that the last statement of my proof is that angle 1 is congruent to angle 2. That's the goal here. So same sort of process. AB parallel to CD, because that was the information they gave to me. Angle 1 is congruent to angle 3. And angle 4 is congruent to angle 2. Because, again, those are vertical angles, and vertical angles are congruent. And now, for angle 3 and angle 4, to state that those are congruent, I could use the same reason we used for the last one. When parallel lines are cut by a transversal, they form congruent alternate interior angles. Then again, if 1 is the same thing as 3, I could just substitute in a 1 right there. And if 4 is the same thing as 2, I can just substitute in a 2 right there to state that 1 is equal to 2 by the property of substitution. So very similar process. It's looking to see what causes what. And now notice that for statements 2 and 3, I could state that those are alternate interior before I talk about the vertical angles. So these could actually go in either order. And the same thing happens for the previous problem. Number 3. Prove the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So for this one, I don't want to use the fact that it's a straight line. I want to find some other way to get there. Now, if I'm looking at these arrows on those lines, that's just telling me that those two lines are parallel. So that's going to be the first thing I put in my proof. The statement is that they're parallel. The reason is that they're given. And now I need to look at the picture. There needs to be some analysis here. So before I even start writing my proof, I'm hoping to look for maybe some alternate interior angles because I know I have parallel lines. So let's see what we could do here. If I look right along here, I can see this z right here, and I notice I've got another z right here. So from that, I could say that this angle and this angle are congruent, and that this angle and this angle are congruent. So what that looks like in a proof is that angle 1 is congruent to angle A, and angle C is congruent to angle 3. Reason being, again, is that parallel lines cut by a transversal form congruent alternate interior angles. But now I'm stuck again. I don't have any information to relate 2 to the rest of the angles. But I notice that this green shaded figure here is a triangle. So that if I add up angle A, angle 2, and angle C, they should sum to 180, because the interior angles in a triangle sum to 180 degrees. And now I notice a very similar pattern as to all the other problems. A is the same thing as 1, so I could just plug in angle 1 right there. And C is the same thing as 3, so I can plug in 3 right there. Again, this is a substitution problem, so I can state that angle 1 plus angle 2 plus angle 3 equals 180, again because of substitution. 4. Given that AB is parallel to CD and you've got that transversal EF, I want to show that BGH and DHG are supplementary. So before I even think about writing a proof, I try to connect these angles to show that they're supplementary in some way, just to get some informal argument of how we could write up the proof. So I know with parallel lines we do a lot with alternate interior angles. So maybe if I say that CHG and BGH are congruent because they're alternate interior, that would help me. And then I could state that these two, CHG and DHG, are supplementary because they form a linear pair, and then I could work backwards with some substitution from there. So let's take a look at what that proof looks like. Now, your proof doesn't need to look exactly like mine, as long as you got to the same conclusion. So I gave my givens, said that BGH is equal to GHC. So again, those are my alternate interior angles here. And then I said that GHC and angle DHG equal 180 because angles that form a linear pair are supplementary. And now I've got another substitution I can make. BGH is the same as GHC right here. So I can just replace GHC with BGH to get exactly what I'm looking for. Now notice for my step for number 2, I didn't write it out the whole thing, but on a test I expect you to write out the entire definition. Number 5. In the figure to the right, prove that M is parallel to N. So we don't know that those lines are parallel. We want to do something with those angles to prove that they're parallel. So I can't use corresponding angles, I can't use alternate interior. I need to get to some conclusion that helps me see that those lines are never going to touch. And they give me some angles here, but nothing's labeled. So I just went ahead and labeled the angles 1, 2, and 3. You could label different angles. You could do this a bunch of different ways. Here's the way I chose to do it. If I'm analyzing this, I notice that these two angles right here should sum to 180. So 180 minus 138 will give me 42 degrees. So angle 2 is 42 degrees. And now I notice that if these were parallel lines, these alternate interior angles would have to be congruent. So, since I have alternate interior angles that are congruent, that proves that these lines are parallel. So anytime you have parallel lines, the alternate interior angles are congruent. Or if you have alternate interior angles, then the lines are parallel. So let's take a look at what that proof looks like. I stated my givens, and then I said that angles form a linear pair supplementary. So that's for angle 1 and angle 2. And I know that angle 2 is equal to 42 degrees by the properties of subtraction. I just subtracted 138 on both sides of the equal sign. I said that angle 2 is then congruent to angle 3, just by a substitution property. Because even though we're using numbers, angle 2 is 42, and angle 3 is 42. So I could set them both equal to each other there. That is enough to prove that the lines are parallel. So what I said is my reason is that if two lines are cut by a transversal and form alternate interior angles that are congruent, then they are parallel. So if you have congruent alternate interior angles, then they are parallel. And the relationship works both ways.